So let's find the maximum sequence value of array, which is a hard problem. You've got an integer array and a number k, and you're looking at a subsequence of size 2k, such that the first half, when you OR everything and you XOR this value to the OR value of the second half, then you get the maximum value possible, right? Might be a bit abstract. The easiest thing to do is look at an example. Here, you have to pick 4 numbers and keep the order. So we could pick 4, 5, 6, 7, right? They said it's the maximum value we'll get, and you do the OR thing on the OR operator on 4 and 5, and what will you get? Well, you will get 0, 1, 0, 1. That's what you should get. So that's 5 in binary representation, because 4 or 5 is actually 5, and 6 or 7 will get you 7, right? Because 6 or 7 in binary notation is actually 7. And then you have to XOR both of them. So 0, 0 will give me 0, 1, 1 will give me 0, 0, 1 will give me 1, 1, 1 will give me 0. And so that's 2. And if I loop over all the possible subsequences, I'll see that the maximum value I can get is 2. And so I need to find this maximum value in a sort of reasonable time. If I try to enumerate all the subsequences, that might be too much, right? But we can look at the constraints. We have up to 400 numbers in the array. The numbers are quite small, so that'll be important. And obviously k can't be more than half of the array, because you want a subsequence that's 2k. So if k is bigger than the half, then you can't really find a subsequence that's bigger than the array itself. So if you enumerate all the sequences, the subsequences, well, you have to choose 2k elements among n, and that's obviously a lot. That's like way too much for the constraints. Like if k equals 200 and n is 400, 400 choose 200 is way too much. So the idea is still to try and get take advantage of those quite small constraints. And the idea is the numbers are not big. Because the numbers are not big, the OR value you can get, so that value here, will never be bigger than 2 to the power of 7 minus 1, right? Because we know all the numbers will be smaller than 2 to the power 7, so they're all smaller than this. So the biggest number you can get, so this bit, which is the 7th bit, the 8th bit, can never be on. And so the best value you can get will be 2 to the power 7 minus 1, because you can, with all values, or maybe you have this value in your array, and that's the biggest value you'll get. So you can have at most 2 to the power 7 minus 1 different values for this part. And similarly, you can have 2 to the power 7 minus 1 values at most for this part. It just happens that if we do 2 to the power 7 minus 1, it's 127. So it's not that big. So if we enumerate all the values we can get on the left side and all the values we can get on the right side, and then we try to XOR all of those pairs, well, our complexity will be 2 to the power 7 minus 1 squared, which is around 10 to the power 4, which is fine. So if we can enumerate all of these easily, then we have a solution that's very, very fast. Now the question is obviously, how do you enumerate all of them? So to enumerate all of them, we'll use dynamic programming, and the idea is we will define, let's only focus on that part first, right? Because if we can do this, it'll be easy to just do the symmetric for the other part. And we'll define dp dpij, right, as a set. And this set will be all the possible OR values of all possible OR values. And we just proved that this set won't be that big, okay? So what are I and j? So as a set of all possible OR values, by taking j elements from num all the way up to I excluded, right? So why would we do that? Well, the idea is if we know the set of possible values we can get by taking j minus 1 elements, right? If we want to know what are the possible OR values we want to take by taking j elements, we just need to add one element and to OR it with all the sets, with all the elements of the set, right? And because the constraints are really small, that's, even though it's expensive, that's fine. So what's the transition? But no, sorry. Before talking about this transition, maybe the first thing to say is the initialization of our array. Obviously, we'll put empty sets everywhere, except for, I'll take another color. For those of the form dpi0, right? dpi0 means we take 0 values all the way up to I, and so we'll just add 0 to this. And for dpi1, which is even more important, well, you can get one value up to nums I. That's nums, I think. Yeah, they call it nums. So this is going to be, well, the set of all values between nums 0 and nums I, right? So it could be nums 0, it could be nums 1, all the way up to nums I minus 1. So that'll be our initialization. And then the transition is, if we look at dpij, right? So I can go all the way up to I and I can take j elements. Well, obviously, if you can take j elements up to I, you want to be able to take j elements up to I minus 1, right? So at least you have dpi minus 1 j, right? At least. So you can merge those two sets. And then if you want to take an element, the element at position I minus 1, so remember, this is up to I minus 1 and this is up to I minus 2. If you want to take, let's say, if you want to take the elements of at I minus 1, you're only allowed to take j minus 1 elements from I minus 1, j minus 1. So you'll loop over all the elements of I minus 1 and j minus 1, because you're not allowed to take j elements anymore, because you know you'll take the I minus 1 element. And then you'll add this to your step, to your set, sorry. But you won't add t, you will add t or nums I minus 1, right? So the idea is I take j minus 1 elements here, all of them, I get t, and then I add I minus 1. And so that's pretty much how you get all the possible OR values you could get in this first part. And I won't detail it, but we'll code it together. The same thing can be done for that part. And then we can just enumerate, as I said, all the possible pair between this set and this set, and return the max value. So I think it'll make more sense when we code it up. So let's do it. Let's call n the len of nums, right? And we'll call our array dp first part, and then we are going to build a dp second part array, right? And those array are lists of sets of integers. Lists of sets of integers. And initially we put just empty sets everywhere. And so we have to remember dp first byte I j is a set of all values, get j elements from nums all the way up to I minus 1 included. Okay, and we are sure this set won't be of size bigger than 2 to the power of 7, right? Which is 127, which is really, really small. For our initialization, we said we'll try to do dp first part I0 and dp first part I1 will be the things we initialize. And so we'll say, now that I think about it, we probably don't have to care about that part. So I'll try not to care about it, and then if we make if we see on one of our test cases that we make a mistake, then we can just understand why we're making a mistake. But I think the only thing we have to initialize is this, like when we take one element up to I. And when we take one element up to I, we want to say this, I want to add any nums L such that L is smaller than I and bigger than 0. So just have to loop over all the elements up to I. Obviously, we have like a quadratic complexity here, we have a quadratic complexity in space. At the end, we'll generate all the pairs, but everything is under 10 to the power of 3, so we're really fine with this, at least for now. So that's the initialization, and now we'll do the transition, right? And the transition is we'll go from 1 to n plus 1, and we'll take j. So j, we have to be careful. We can take at most k elements, right? So intuitively we would think that that's the bounds, but actually if I is smaller than k, right, we can't really take 10 elements if we only consider the 5 first elements of our array. So we have to be careful here and say, well, I take the minimum between I and k. And the first thing I do is I can take j elements from nums I minus 1, right? That's perfectly allowed. So I have to say dp first part I, j, and then merge this with the set that's currently at dp first part minus I minus 1, j. And then the second thing is I can take j minus 1 elements from nums I minus 1 and 1 element and nums I minus 1, right? For a grand total of j elements. So that's, I'll loop over all the elements of dp first part I minus 1 and j minus 1. I loop over all of those. That's not a range, sorry. Just loop over everything I can get when I pick j minus 1 elements, and I add to my current array, my current dp cell, t or nums I minus 1. It's not equal, is dots add. Here again, right, this is n, possibly n squared times at most 100. We're really fine with the complexity. And now I have everything, right, for dp first part. I just need to generate dp second part. The dp second part is going to be almost the same, right? I generate dp second parts, initialize it the same, and here I'll say that it's a set of all values except instead of ending at I, I'm just going to start at I, right? And I'll initialize only this. Initialization. So here, instead of L going from 0 to I minus 1, I'll go from I to the end of the array. And then I do TP second part I1 dot add nums L. And then transition, right? It's again quite similar. Here earlier I was going, right from I'm not allowed a lot of elements to I'm allowed more and more and more elements. Here we can just do the same, right? If we go that way, at the beginning we only allowed like one element, and then we allow more and more elements. So we'll just go from the end, right? This is not the only way to do it. It makes more sense to me, but maybe it doesn't make much sense to you, in which case you're more than welcome to change it. So I'll start at the end of the array, so that's n minus 1, I'll end at 0, so I have to write -1 in Python, and my step size is -1. Then I have to do the same thing. I have to be careful that if I'm allowed to take 10 elements, I shouldn't, so if I'm allowed 10 elements, right, I should have at least 10 elements at the end of my array, right? So instead of min ik, it is going to be min n minus ik, right? This is the number of elements I'm currently allowed to take j from. And then I'll do the same. TP second part, ij, I'm allowing myself to take from, instead of nums I minus 1, it will be nums I plus 1, right? So maybe I should write it. I can take j elements from nums I plus 1, right? So I'll do TP second part I plus 1 j. And this will be done, right? By the time I get to I plus 1 is already done because I'm starting at n minus 1. So that's perfectly fine. And the second thing is I can take j minus 1 elements from I plus 1, and I take nums I this time for a grand total of j elements. TP second part I j, let's add t nums I, and I have to loop over all the elements in I can't copy TP second part I plus 1, and I'm only allowed to take j minus 1 elements. Alright, this is really the symmetric of this first part. And yeah, I had written this for no reason. And then the last part is I loop over this. In the nested loop, I loop over this, and I try to get the maximum, right? So ons is going to be 0. I loop over, so maybe I simplified a bit, because I have to say I divide my array here, and I loop over all the possibilities here and all the possibilities here, or I divide my array here, and I loop over all the possibilities here, all the possibilities here, etc., etc. So we'll have 3 nested loops, right? First, I need to decide where I divide the array. So I is going to be where I divide the array. I can't divide my array before k, right? Because I have to take k elements. And I can't divide my array after n minus k, because I have to take k element, right? If n is 10 and k is 1, and so my array looks like this. I have to start my division here. I can't start at 0, so I start at 1. And I don't want to stop, well, I don't want my division to be further away than position 9, right? So, but position 9 is allowed. So I'm just missing a +1. So that's basically what I'm saying, right? If it was k equals 4, my division is only allowed here up to here. So we'll have 3 nested loops, but again, the first nested loop is 400, and the other 2 are 127. That's perfectly fine. So the possible, or call it A, is a set, right? It's dp first part all the way up to I, and I can take k, and possible or B is dp second part, also I, right? Except it means I'm starting at I, and also I want to take k from it. And then from T1, for T1 in possible A, for T2 in possible A, or B, sorry, right? Max between what I currently have and T1, T2, right? This is my new answer. Answer is the max between what I previously had as a max and the new XOR I can make, XOR I can make. And then I just return. So hopefully that should be fine. I probably made a mistake. We'll just see under the custom test cases first. And yes, we did make a mistake. I forgot, well, yeah, when I initialize my array, so that's a set, that's the j dimension, and I forgot to initialize the I dimension, so that's for I in range of n. Is it n or n plus 1? It is n plus 1. Right, because I is excluded, right? So it'll go up, you'll go up to n, and n is excluded, so that's the Pythonic way. And yeah, I assume I forgot here. So does it work now? Okay, it works. Hopefully it'll work here as well. Let's see. Well, yes, it does. Perfect.